Welcome back, everybody. In this video, I wanted to go over some of the meanings of the operations addition, subtraction, multiplication, and division. And the reason for that is when we get around to studying story problems, word problems, it's very helpful to know how to translate the story into what calculations or operations need to be performed. And for that reason, it's a good idea to know what exactly is meant when we talk about addition, subtraction, multiplication, and division. So let's start with addition. So addition is the easiest, in my opinion, and probably you're likely to feel the same way. Usually we use addition when objects are going to be combined. We have a certain number of something and a certain number of something, and we put them together and we want to know the total, or how many there are altogether, then addition is called for. So as an easy example, there are 5 birds in a tree, 6 more birds land in the tree. We want to know how many birds are in the tree now. Well, then that problem can be answered by saying, well, we've started with 5 birds, 6 more birds in the tree, so in all there's 11 birds. Okay, so here the calculation may strike you as easy, and that's okay. The emphasis for this video we're doing now is not to focus on the difficulty of the calculations, just on making sure we understand the concepts behind the different operations. So for that reason, I'm going to be keeping the calculations relatively straightforward. So the point for addition, you've got some objects, you're combining them, you're putting together a couple of things, and you want to know how many total things there are, whatever they are. Wording that can indicate addition is called for altogether. Some amount increased by another amount, or the total. Also, you can see the word sum. The sum is the answer word for an addition. Okay, so that's addition, putting together of objects. Subtraction, you have to be a little more careful. There's in basically 3 ways of thinking about subtraction. So we're going to look at each of those in turn. The first one you learn when you're a kid especially is takeaway subtraction. And a lot of times if you listen to kids, they will say, okay, 5 take away 2, right? Because it's easier than saying subtract or minus, okay? Takeaway is used when you have a certain amount of something and you're taking some away. And so that's kind of the backwards or opposite of addition, where you're putting things together, taking things away, that's subtraction. So example, Emily has 12 chips and she eats 5. We want to know how many chips she has now. Well, this can be answered with this calculation. Starting with 12 chips, we're going to take away 5 chips. That will leave 7 chips. Okay, taking something away. We have some amount, we're taking some of it away, and we want to know how much is left, what is remaining. Okay, Al has $1,600 in the bank, and he withdraws $120 for groceries. We want to know how much is left in the bank. So this can be answered by saying, well, 1,600 minus the 120, and that will be 1,480. Okay, so he's going to have 1,480 left in the bank. Okay, takeaway subtraction. Starting with some amount, we take some amount away, and we want to know how much is left. Okay, the next type of subtraction you're going to see, or you can see, is called missing addend subtraction. Remember that an addend is a word for a number that's being added. Okay, so a missing addend suggests that there's one we don't know, and we're going to try to find it out using subtraction. Examples of missing addend. Jen wants a book that's $50. She has $30. We want to know how much more does she need, right? So this could be answered by thinking the following way. She has $30. We want to add to it some amount, and she needs to end up with $50 in order to buy the book. The $20, you probably already thought 20, and you're right. The $20 you get by saying, well, 50, the amount that she wants to end up with, minus the 30, the amount that she already has, leaves 20. She needs $20. Okay, so one thing that is kind of tricky about this potentially is the wording here and what's going on with it. If you think about what's physically happening, Jen has a certain amount of money and she's getting more, right? Or wants to get more, that other $20. And when you think about getting more, that sounds like addition, right? If you'd like to have more money or get more points on your test, right? That sounds like you're getting more. But to answer the question, how much more is needed to reach a certain total, subtraction is actually used, right? So you have to be careful and think about what is actually going on in the problem. Okay, missing addend. Okay, another example. Al is 40 inches tall. He's a little kid. So Al is a little kid. He's 40 inches tall. He needs to be 46 inches tall in order to ride a water slide at the water park. We want to know how much more does he need to grow? Okay, well, he needs to end up being 46 inches tall. He's currently 40 inches tall. And so taking the difference between what he needs to be and what he is now, that's going to be 6 inches. So he needs 6 more inches that he needs to grow in order to ride the water slide. Okay, so what's important to note here is that although we're doing a subtraction to answer this question, it's because we're trying to find an amount needed to make a certain total. We're not taking anything away here, which is why you might not think subtraction at first glance. Okay, but if you're trying to figure out how much more is needed to reach a certain total, that's a missing addend subtraction type problem. Okay, comparison is the next way of interpreting subtraction. Frequently, we use subtraction to do comparison. It's going to turn out later in the course that we can use division for subtraction as well in the form of rates and ratios and fractions. For now, we're going to use subtraction for comparison. As an example, suppose that Jill is 18 years old and Isabella is 6. We want to know how much older is Jill. So we're comparing Jill's age, which is 18, and Isabella's age, which is 6. And so we'll say Jill, who's older, minus Isabella, who's younger, that's 12. 12-year difference. So we could say Jill is 12 years older. Okay, again, we're not taking anything away, right? We're not taking some of Jill's years and giving them to Isabella, and we're not trying to add something. We're not trying to say, okay, we're going to give some years to Isabella, but instead we're comparing two values. We know one's bigger and we want to know how much it's bigger. Okay, next, a blue used car is $5,600 and a red one is $4,000. We want to know how much cheaper the red one is. So again, we're comparing prices this time. We're comparing a blue car and a red car, and we know one's cheaper. How much cheaper is it? So we're going to compare via subtraction. So we have the more expensive car at $5,600. We're going to subtract the cheaper car at $4,000, and that is going to be $1,600, sorry. Okay, so the cheaper one, the red one, is $1,600 less. Okay, $1,600 less. Okay, so again, we're using subtraction to achieve our comparison. Okay, so subtraction has 3 different ways of thinking about it. So you want to be kind of careful. There's more to it than there was with addition. Okay, multiplication is next. There's basically 2 ways of thinking about multiplication. The one that you're potentially most familiar with is going to be repeated addition. Multiplication is useful when you need to add fast. You need to add over and over and over again quickly. As an example, Jamil buys 6 tubes of glue for $4 each, and we want to know how much is it for all the glue. Okay, so that means that we're going to add together 4s 6 times. So that's 6 times 4, or $24. Okay, so it's $24. What this reminds me of is it's always unfortunate when I see students take paper tests and they don't know the multiplication tables very well. And so they sit there going 4 plus 4 plus 4 plus 4 plus 4. There's 1, 2, 3, 4, 5, 6 of them, and they're just adding on their fingers over and over and over and over again, trying to get to that 24, right? Make sure you know your multiplication tables so you're not doing things like this, because that's going to be tiring for you. Okay, multiplication is a way to add over and over again quickly. Okay, to buy her car, Liz pays 60 payments of $340. We want to know how much the car costs. Of course, none of us want to see me write 340 down 60 times, right? We're going to be here all day if I write down 340 60 times. So instead, we'll say 60 times 340. Okay, we're going to use multiplication to get that done. Okay, so let me go ahead and get this taken care of. So 340 times 60, I'm going to do 34 times 6, and then I'll adjust by adding in the 2 zeros afterwards. Okay, so 6 times 4 is 24, 3 times 6 is 18, plus 2, that's 20. So 2, 0, 4, and then each of the factors had a 0 on it, so our product will have 2 more zeros on it. So that's 20,400. Okay, so her car cost 20,400. So the important point is that we're going to use multiplication as a fast way of doing addition. Okay, the second interpretation is area. We've seen that the area of a rectangle is achieved by multiplying its height by its width. You may have experienced in your past life of a formula like A equals H times W, or width times length, or base times height, all of which mean the same thing. We're going to multiply the two directions together, the two dimensions of the rectangle. So here, if we have this rectangle that measures 3 inches by 4 inches, to find the area, it's going to be 3 times 4, or 12, and that will be in square inches. Of course, thinking of area, this really goes back to the previous interpretation we had, which was repeated addition, because you can think of that rectangle that's 3 inches by 4 inches as consisting of rows of squares, and there will be 3 rows in it, and 4 squares within each row. And so if we want to figure out how many squares there are, nobody wants to see me go 1, 2, 3, 4, all the way up to 12, right? You say, okay, well, there's 4 in the first row, 4 in the second row, 4 in the third row. That's 4 plus 4 plus 4, which of course is the same as 3 times 4. So in a way, when we say height times width for the area of a rectangle, we're counting up rows of squares. Okay, and so again, that is going to be repeated addition. Okay, so last one is division. So we're on to division next. What division's for? Often people have a hard time with division, so it's definitely a good idea to pay special attention to it. What division is for is when you have some whole amount and you're putting it into groups of equal size. Okay, so you have your whole bag of cookies that you bought at the grocery store and you're splitting them up for your school lunches. You have 200 kids who are going on a field trip and you can get 50 kids on each bus. You have some whole amount and you're putting it into groups of equal size. What division tells you is one of two things: either how many groups you get or the size of each group. Okay, it tells you one of those two things. So picture having a whole amount of something and you're putting it into chunks of equal size. And so what division will tell you is how many groups you get, how many chunks you get, or how big each chunk is. So let's try some examples. Okay, let's say that you have a box of 24 cookies and you eat 3 every day. How long will they last? Okay, well, we're taking 24 cookies. Picture doing this, okay? Visualization can help you. Picture you have the whole 24 cookies. If you put them into piles, 3 cookies for the first day, 3 cookies for the next day, 3 cookies for the next day, how long will it take till you run out? Well, you're putting a whole amount, 24 cookies, into piles of size 3. You're going to get 8 piles. So it's going to last 8 days. Okay, notice again that you do need to have groups of equal size, right? If it's not equal size, there's no way to answer the question. What if I said to you, you have a box of 24 cookies and you ate some of them every day? Some of them. If you ate some every day, there's no way of knowing how long they're going to last. What if you eat 2 the first day and 11 the second day, and then the rest of them the third day? Okay, if you don't know that it's the same amount each day, there's no way to answer the question. So fundamental, that is basic for division, is that it has to be the same amount in each group. Okay, suppose that you have to write a 24-page paper and you have to finish it in 6 days. Okay, how many pages must you write each day? So again, we're going to assume that you're going to write the same amount each day. So you have a whole amount, this 24-page paper, and you're going to split it into 6 piles. Okay, if you're going to split it into 6 piles, each one being a day, we want to know how big each group or each chunk is. So 24 divided by 6 is going to be 4. So 24 total pages put into 6 days is going to be 4 pages per day. Okay, in the first case, we had 24 of something, and we put it into a known group size, a known number of cookies every day. And we wanted to know how many chunks we'd get, how many groups. In the second case, we had a whole amount, again, it was 24, and we're putting it into a fixed number of groups. That is the 6, and we want to know how big each group would be. Okay, so once again, it's going to be division. Okay, an important tip going forward is you want to pay attention to where you are in a course. If we're just at the beginning working on whole numbers, right, and we haven't done any decimals, fractions, percents, anything like that, negative numbers, then for your first test, which is just on whole numbers, you shouldn't get any decimals or fractions or percentages. So let's just say your test covers only whole numbers, right? You're just in chapter 1, and you're asked to do a division like 32 divided by 4, and you mess it up somehow and you get 7.75. Okay, well, it's wrong, right? We don't have to do any work to know it's wrong, just based on the fact that, well, if we haven't covered decimals yet, there's no way I should be getting a decimal as an answer. Okay, so take advantage of the fact that early on, you're not expected to be doing work with decimals, negative numbers, fractions, anything like that. So for the purposes of a first test, you should just get whole number answers. Okay, so that takes us to the end of this. Our purpose was really to look at some meanings for addition, subtraction, multiplication, and division. And those will help guide you when you form story problems. You read through the story, you understand what's going on. Are we having something and something is being taken away, and that's a subtraction? Are we comparing two things, and that's a subtraction? Do we have a whole amount of something put into groups of equal size? That sounds like a division. Okay, thinking about what the meanings of the different operations are is going to help you in constructing your solutions for story problems. Anyhow, that takes us to the end. Let me know if you have any questions, and then have a great day.